I
Yeah,
really appreciate
thank you.
you guys. Okay, we are now recording. So hello everybody. I'm Isaac slash the Vividen, and we're going to be talking with some sauropod experts about their upcoming project that they're currently crowdfunding. It's an awesome open access volume of a lot of sauropod research. So let's go ahead and talk about this. Colin, do you want to take it away and start us off? Just kind of give
Yeah,
us a basic rundown.
sure. So I'm I'm one of the newest researchers on the scene with this volume, but my team is specifically looking at biogeography of diplodocoids, using the Shop et al. 2015 matrix to do so. Our paper is still in review, but I'm actually having my team look at comments right now, and so we can send it back hopefully soon with the revisions in hand. And then this volume focuses on the systematics, taxonomy, and biogeography of Diplodocus, which is a very important series of subjects, especially because despite the fact that, hey, we know Apatosaurus, we know Diplodocus, well, there's also now Brontosaurus, and there's Catodocus, Gallimimus, Supersaurus, Barosaurus. How do they all fit? How are they all related? Who's related to who? And in the case of biogeography, where are they coming from and where are they going? And so this volume sought to bring researchers from around the world by Emmanuel Tschopp in order to answer and ask some of these questions. And he's been doing a phenomenal job. And we have a lot of great contributions from different scientists. And what's interesting is the journal that we're publishing with, Paleontological Electronica, normally is free. They don't have an APC or article processing charge when you submit a paper to them. But because we're doing a special volume with them and that requires special work, they are charging a special volume APC of $3,000 for up to 20 papers. Now, for comparison, some journals charge almost that amount of money or that amount of money sometimes for one paper. And this is the charge for up to 20 papers. So, yeah, but we are therefore crowdfunding on experiment.com, which is similar to GoFundMe, but for scientific experiments. We're trying to crowdfund to help pay that APC to Paleontological Electronica on experiment.com. Right now, we're almost at $2,500 of the 3,000 needed, so we're over 80% of the way there. Yeah, with about 3 weeks left. So we're really close. So please, 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 if you could share or donate, anything helps. And any extra money we get after we've paid the APC and we pay the processing fees to experiment.com is going to go towards paleo artists to help with creating paleo art for this special volume. And so we're really excited to hopefully hit some stretch goals and make that happen.
I think it sounds like an absolutely amazing project. I'm a huge fan of open access science and journals. I think it is the way to go. Emmanuel, you mentioned that you were kind of the one that started this. Would you mind talking about A, why focus on diplodocoids specifically, and B, what the motivation was to make it an open access volume?
Yeah, sure. Well, I'm kind of focused on diplodocoids or even a specific subgroup of diplodocoids, diplodocids, or I've been focusing on that since my PhD, and published the big analysis of my PhD in 2015 that Colin mentioned earlier, um, where I reanalyzed the systematics and evolution of the group, based on a specimen level analysis. Um, that kind of hit the press quite heavily because one of the results was that we consider Brontosaurus valid again after more for 100 years in scientific oblivion, basically. Um, that has been 10 years since then, and a lot of exciting new specimens of this group have actually been found or worked on since then. So, and for several of these descriptive works that were in progress, people have invited me to contribute and to help with the phylogenetic analyses. Now, at some point, I thought it doesn't make sense to crank out
a number of papers with phylogenetic analyses in there that are just slightly different from each other, and that it would make more sense to combine everything into one big analysis with all the specimens actually already in there, so they can also be compared directly. And luckily, all of the contributors or all of the people who initially invited me were happy to follow my invitation for them to contribute to the volume. Um, so in the volume will be these descriptions of the new specimens and a big phylogenetic analysis based on the 2015 paper and some additional work that has been done since then by John Whitlock, for example, or also some upcoming work that is, I guess, soon to be published by Drew Moore. Um, so yeah, it's exciting, and I mean, already the 2015 paper was open access, and I think that's the way to go, as you said. I want this to be available for everybody, not just scientists, and also scientists all over the world who might not have the money or the funding to access articles behind paywalls. But for a journal like Paleontologica Electronica, who doesn't have a big budget, taking on a series of very long descriptive papers, like what we propose, is a huge additional amount of work for them that they have to pay somebody to do this. So it makes sense that they ask for this comparatively small amount of money. And yeah, we hope we can get some help through this crowdfunding campaign to actually support the journal as well in their open access mission.
It's definitely a great move by Paleontological Electronica to host that and to make it a feasible amount of money that we can get that to happen. Uh, Andrew, I saw in your profile in the experiment.com that you focus on evolutionary anatomy. Would you mind talking a little bit about kind of where your angle is with this project and some of the knowledge that you're bringing to that?
Yeah, sure. So I describe myself as an evolutionary anatomist because increasingly I don't just work on sauropods. I have sort of two wings of things. And so I'm not strictly a paleontologist, although a lot of the work I do is paleontologically oriented, and that's sort of why I'm here as part of this team. But I'm trained as a systematist, and that's fundamentally evolutionary anatomy, using anatomy to try to figure out the evolutionary relationships of, in this case, sauropod dinosaurs. But I also use that term to sort of encompass work I do on the evolution of lungs in birds and trying to reconstruct soft tissues in things like sauropods. So I actually got interested in sauropods because I was interested in this phenomenon of skeletal pneumaticity. So I look at sauropods because I like skeletal pneumaticity, trying to understand its extremes in the fossil record. But birds are the only living vertebrates that have um, air-filled bones in the same way. So they're a good study system. Anyway, that's just sort of why I use the term evolutionary anatomist. But in terms of this project, I'm actually not exactly a content expert for diplodocoid sauropods, at least not compared to a lot of my peers here. Although, as Emmanuel mentioned, I do have an upcoming paper with Phil Mannion, another sauropod worker, that does revise some aspects of sauropod phylogeny or diplodocoid phylogeny. But that was actually born out of a larger project that he and I have ongoing to incorporate more observations from earlier in sauropod evolutionary history, sort of earlier branching than Diplodocoidea. So my expertise when it comes to sauropods more so concerns a lineage of predominantly Chinese or East Asian sauropods called Mamenchosaurids. And so my role in this volume is really the phylogenetic analysis component, but helping to beef up some of the observations for some of the outgroups that are relevant for polarizing characters in diplodocoids. I have studied some diplodocoids too, but compared to Emmanuel and some of the others here, not so much. But one of my aspirations, actually, sort of inspired by Emmanuel's work in 2015, is to do the same sort of thing that he and his colleagues did there, but for this almost equally diverse lineage of Chinese sauropods called Mamenchosaurids. There's something like 27 or more probably now. That was my last count, but I don't remember when I took that. Chinese sauropods that might belong to this lineage, but most of them haven't been studied with the level of detail we'd like. And so this is a good way to be involved in a project, specimen-based project, really fleshing out the systematics of a group and then applying the same sort of principles to another lineage that I have a little bit more direct expertise in.
That's awesome. Kind of taking that same methodology that Emmanuel used and then
Yeah, I think
applying
it
it to
inspired a
something
lot
that,
of
yeah,
yeah, I think it inspired a lot of us to think along those lines. There's actually quite a lot of power in taking the specimen level approach, and that had not been something that was typical really before that point. So for sure.
that's awesome. Okay, I've got a question kind of aimed towards our general, a little bit less technical audience. So sauropod dinosaurs are obviously incredible creatures, and the part of sauropods that the public generally recognizes first off is how big they were. But I want to know from each of you, what is the thing about sauropods in general, or diplodocoids specifically, besides their body size, that fascinates you the most?
I think I already gave away my answer in my last response. But for me, it's the phenomenon of air-filled spaces in bones. So we as mammals, as humans, we only have air-filled spaces in our skull. So when you get a sinus infection, that is an air sinus. A sinus is just a space. We also have blood sinuses in our body, but an air sinus is a air-filled space in our bones. Mammals only have that in their skulls, but birds and many of their dinosaurian extinct relatives have air-filled spaces in their postcranial skeletons, and that results from a rather different setup of their lungs than mammals have. And so it's widely understood to be an important adaptation for body size. So I guess you can't quite escape that body size question. But that phenomenon, sort of why pneumaticity is variable in the ways that it is, and actually what sort of structural consequences it might have for bones, is quite interesting to me. And for sauropods, since they're pushing the extremes of body plan, what seems like it should be feasible, how pneumaticity plays a role in that is quite interesting to me.
That's pretty amazing. Emmanuel and Colin, what are your thoughts on this question? What fascinates you the most about sauropods besides body size?
And you want to go first?
Sure. What interests me a lot is how these sauropods and especially diplodocids could get so diverse and abundant, being so large. So it's more of a ecological question, also, and the best or one of the best places to actually study this is the Morrison Formation in North America, where you also have by far the largest diversity of diplodocids that has been described so far. And it's just kind of mind-boggling of how all these different species could live there, maybe together. That's probably the main question to solve. Which species actually live together at the same place at the same time? And how they, well, if they had to kind of compete for food, or if there was just enough food for them anyway. Uh, and then if they had to compete, how they competed for food? What was the difference? How did they differently use their environment, and stuff like this, just to figure out more about how basically nature worked in the past.
Yeah, the Morrison is a crazy formation in a lot of ways. And so understanding that diversity and how it works on a ecomechanical level is super important.
Yeah,
Colin?
but I guess the main thing here is also, before we can do that, we actually have to know which specimen belongs to what species. So all these specimen level phylogeny, or this description of new specimens, they are the most important first step to actually start asking those ecological questions.
For sure. You got to have the same baseline to understand what questions you're even asking.
Yeah, also.
All right, my turn. Um, A very, very simple answer, but it's more complex, is neck biomechanics. I really, I think,
Yay.
would become in awe of sauropods studying neck biomechanics for my master's. I mean, it was incredible seeing just how sauropods do hold their necks, and then I think coming to the realization that it's like, well, it really probably does differ between clade and possibly even species. So neck biomechanics is almost a species by species comparison you have to do and then can make, rather than like all sauropods had this posture. I'm of the opinion, no, it probably differed by clade from everything we've seen about sauropod anatomy because they're so different. I mean, Apatosaurus has such short cervical ribs, and meanwhile, as I remember correctly, Mamenchisaurs actually have incredibly long cervical ribs, which would impact neck biomechanics. Going a little deeper, like Emmanuel, I'm also both fascinated, intrigued, and in love with this idea of what I call the Coeval Morrison sauropod issue, or CMSI, aka why are there so many large-bodied sauropods living in the same place at the same time? And we know from certain quarries, like Dry Mesa Dinosaur Quarry or the Carnegie Quarry at Dinosaur National Monument, that we have at least three large-bodied sauropods living together. And then besides those two things, I also am really fascinated also by not only the evolutionary success and diversity of sauropods, especially diplodocoids, but especially probably more so with specific groups of sauropods than others. Um, I'm a Saurischian guy, and I love Allosauroidea as a case study group and as a theropod clade. And there's a very intertwined relationship between sauropods and Allosauroidea. And so I've always been intrigued by that relationship as well, that ecological kind of, yeah, back and forth that these two clades have. So, yeah.
Yeah, I think that's awesome. You can never really truly study an organism in a vacuum, can you? You always have to look at what forces shaped it, whether those be non-biological forces or the predators that they lived with. So that's a really good point that you bring up. Would you mind talking just a little bit, maybe a couple minutes, whatever you can share about your master's thesis and kind of the conclusions that you came to with that?
Yeah. We're still working to get that published. I'll make this super brief. My master's thesis was focused on BYU 18531, an apatosaurian specimen discovered in Utah, that has a very complete neck. Emmanuel actually discussed it in his 2015 paper. And he found that it was B. parvus or Brontosaurus parvus, so it was part of the resurrected genus Brontosaurus. This apatosaurine, right, so has most of its neck. It's missing the atlas, but otherwise we have portions or all of C2 through C15. And so basically we used a combination of physical and virtual methods to try to reconstruct the osteological neutral pose of the neck of this animal. The osteological neutral pose, or ONP, is kind of considered a foundational pose when you first start talking about um, neck posture. It has varying criteria depending on who you talk to, but it relates to, you have your zygapophyses, or these articular facets on the neural arch of the bone, which is the kind of the top part. In this case, you have those in 100% overlap with each other, and then you have your ball and then the socket on the back. You usually have those of connected vertebrae nestled in each other generally for ONP, and then you see what pose you get. Now, of course, habitual poses for these animals likely differed based on the activity, and therefore these animals may not have held their neck, actually probably didn't hold their neck in ONP all the time, but ONP just gives us kind of this starting position. And then from there, we can start to figure out habitual poses, range of motion, and therefore how these animals fold their necks. And with that, you get things such as, oh, apatosaurians may have held their necks more horizontal or kind of closer to the ground in general as an ONP, rather than the classic S-shaped curve that we see for a lot of sauropods. Meanwhile, other sauropods based on anatomy, such as Brachiosaurus or Camarasaurus, maybe more had a elevated, uh, more vertical ONP, or even just habitual neck posture for these animals. And it is really going to differ. And so it was really good to work with a very complete specimen. I think that's very helpful to help deal with the issues of Mike Taylor had a 2022 paper come out. Almost all sauropod necks are distorted or incomplete. And this specimen had just not that much distortion to deal with, and it was fairly complete. And so, yeah,
Almost kind of a unicorn specimen, really.
a little special, yeah, but it was really nice. So,
That's awesome. Hey, I think I've got one last question for the group, and each person can answer this individually. What is your biggest goal for this project? What is like the dream scenario of what you hope it accomplishes within the broader sphere of paleontology and of scientific communication? See, everybody's got their thinking faces on.
I'm not sure this is actually quite uh, at the scope of an answer that you would want, but one thing that I've quite enjoyed playing the role that I've been playing is just the nature of the back and forth. We have like a Google Doc and emails and things going where we're hashing out what we think is or isn't an accurate description of this anatomy or what this feature does or doesn't reflect its homology. And that, yeah, with such a diverse group of folks who have studied a lot of this stuff themselves, and might have different interpretations, but the opportunity to hash that out, I think is actually just a good model for good phylogenetic science. You know, all of us believe, but I think Emmanuel at the head has really made this a central feature of how this work should be conducted. The more you can bring folks together who have actually spent time with the specimens, not just relying on the publications, which are always, of course, very good, but you really can't know what you know until you've studied the thing yourself. And so having all these folks available to talk about it and hash things out is just kind of fun.
Peer review in real time.
Yeah, exactly.
That's awesome.
I
Yeah, I
think,
think
oh,
I
go
have
ahead.
that same goal, I guess. What I realized when I did the 2015 study is that it's really hard to actually write a description of a trait that everybody interprets in the same way.
Mm,
And that if somebody else starts to use your phylogenetic matrix and read your characters, they might just identify different things in the specimen they worked on than what you initially intended with the description of this trait. And that's obviously a problem if you want to do if you run the phylogenetic analysis in the end, because you're going to get a result that is different from what I guess I would have gotten if I would have worked on that specimen. And that should not be the case. So the goal of this is really that we together with lots of different people, with lots of different scientific but also linguistic backgrounds, can come up with a description for a character, for a trait that they all understand equally. And also that we can produce images that everybody interprets in the same way to illustrate these traits. And yeah, it has been very exciting so far to get all these inputs from all the involved people, and also to hear how characters that I wrote or that I adapted from earlier works are interpreted by other people, and to hear what the problems are with my work in 2015 and to actually yeah, make it better.
So not only quantitatively taking a look at the morphology and the characters, but qualitatively describing it in a way that's universally understood.
Yes,
That's awesome.
exactly. Because many of these traits that we are describing and then analyzing to calculate this phylogeny, the family tree, are qualitative descriptions, because not everything you can measure. Some things you can only describe, and that's really hard to do.
For sure.
On the surface, I'm really looking forward to what we learn about biogeography of Diplodocoidea and, maybe how that can help us with understanding both the diversity and evolutionary success of this group. But a little bit deeper, this volume has been amazing in terms of the fact that it's going to be producing a ton of open access science, which, by the way, the first two papers are already out, both Van der Linden et al., and we have links to both of them on the campaign page, so you can already read the first two amazing contributions to this volume, but that this volume sets a precedent of international collaboration between colleagues on a group that people across the world love, that we can work on to produce a bunch of amazing open access science that can have a large impact for future studies on a great case group, whether it be theropods, ornithopods, or sauropods. Again, who knows? Maybe there will be one day a future open access titanosaur volume that could happen, and they could get, a ton of papers, and that'd be really cool. But I think this sets a really good precedent for fantastic, informative, helpful, insightful, collaborative work between international colleagues, studying what they love, studying what we love.
I'm definitely sensing a common theme between all three of your answers. Basically, this project that you're doing is trying, it's very ambitious. It's setting up a template for the future of how teams of researchers can take a specific group or a specific taxon and just basically become the Avengers, like for that type of research. With the open access aspect of it, the team building and focus on live peer review, and then combining all of the different fields or subfields of research on these animals, like biogeography, evolutionary anatomy, the phylogenetics and systemics, all of it together. I think this should be, in my opinion, the future of paleontology, especially when you're talking about groups like at a family or clade level. So thank you all for coming. I think this has been an extremely productive and enlightening interview. And I'm going to continue to promote the heck out of this project until it's fully funded and we can try and hit those stretch goals and support as many paleo artists as we can, which is something that I love doing. Do we have maybe just like a 10 to 30 second like final final words from each of you before we close this up?
I just want to say thank you. I mean, I really appreciate your efforts in promoting it. And also it's exciting to see, in my inbox every day, all the backers at various levels and the conversation that's happening on the page. So yeah, a huge thank you to everyone who's been interested.
I want to thank all the donors we've already had who have helped us with backing this project. Thank you for all your support and help with spreading the word on the project. Thank you to everyone in the future who's going to help back the project. We, really appreciate it, and we do plan to put all of the backers' names in the acknowledgement sections of our paper, right? So that you were a part of the process, and we are making sure to include you as an additional thank you for all your support and help. um, you know, continue spreading the word. That really helps. And I think, to quote John Goodman, and I think it definitely applies to diplodocoids, it's unlikely anything so huge or captivating will ever pass this way again. And that can be, I think, both applied to Dinosauria in general, of course, as it was originally intended, but we could definitely apply that to Diplodocoidea when we think of them.
Yeah, I lost you for a second there. But I also want to thank everybody who has already backed the project, especially I think we have like 45 backers already. So the support here, or it just feels like amazing to inspire so many people to help us with this. And this, of course, also to you, Isaac, and the other people who are helping us promoting this. You guys are not just promoting the project itself, but also open science and the journal, and especially also several students who actually lead projects that are being published in this volume, like Colin or some others who are not here today, like Tom van der Linden. So yeah, thanks a lot for that.
Thank you, Isaac.
Yeah, thank all of you. I'm just excited to even be a small part of this and promote something that I think should really become the blueprint for science communication and open access science moving forward.